Hardy-Weinberg equilibrium is a set of principles in which allele and genotype frequency have to stay the same over time, and it assumes that there's no evolutionary influence. The conditions are that there's no mutation, there's random mating, there's no gene flow, meaning no new alleles are coming into the population, and a large population, and no natural selection. And in our experiment with the fruit flies, we violated the equilibrium by having the population itself be so small. And we violated the equilibrium again when we introduced 11 vestigial winged individuals into the population, which is an example of genetic drift since we've altered the allele frequency.
As we carry out this experiment, we have fruit flies that have two different phenotypes, one phenotype being for normal wings and one for vestigial wings. The normal winged is the dominant phenotype, and the vestigial winged would be the recessive. Our first prediction is that as time goes on, the amount of vestigial winged flies will increase because for our experiment, week 1 we had 0 and then we added in 11 more vestigials, and by week 3 we already saw an increase in their population. But we also predict that as time goes on, the normal winged phenotype will still remain as the majority because it is dominant and vestigial is recessive. We think that by the end there will be roughly like a 3-to-1 ratio of normal to vestigial.